Okay, so in today's video, we are going to learn how to create confidence intervals on two population means with independent samples with large sample sizes. So it's very important when we create confidence intervals is that we know what type of samples that we have, independent or dependent, and from there we also need to know whether we have a large sample size or small sample size. It's very important to note that because the formulas that you will be using for creating confidence intervals will depend on the type of samples and the type of sample sizes. So let us look at one example on how to create this confidence interval. Example: suppose a study was conducted to compare the average time in days of people who take a certain supplement to recover from a common cold compared to people who do not take the supplement. Their data shows the following results. So we have the two groups with supplement or using the supplement and without taking the supplement. The sample sizes are, we have 50 respondents for the group who are taking the supplement and 48 from without the supplement. The sample mean, these numbers that you see are the average time for each group to recover. This is the number of days to recover from a common cold. So 5.4 means it will take about 5.4 days for those people taking the supplement to recover from a common cold, while 7.2 means about 7 days that the people who are not taking supplement will take to recover from a common cold. The corresponding sample standard deviations are 1.3 and 3.2. So suppose the task is not a hypothesis test, but it's about creating a confidence interval for the difference of the two means with a 95% confidence level. So how are we going to create this interval? Okay, so first thing to note is that our case is an independent or is with independent samples because we have two groups that are not related. Mainly the reason behind is because the group who are taking the supplement has nothing to do with the group who are not taking the supplement. And then aside from that, we have to consider the sample sizes. We have 50 and 48, which are both greater than or equal, or which are greater than 30. So that means we have a case of two independent samples with large sample sizes. If that is the case, so what will be the formula to use in finding the confidence interval? To find the confidence interval, we need to find formula. So this is our estimator. So the formula says we have to find the difference between the two sample means, and then we either subtract, that's to get the lower limit, or add to get the upper limit to the difference. This value that we are adding and subtracting is our margin of error. So basically, the confidence interval is done by doing x1 bar minus x2 bar plus and minus the margin of error e. So to find the confidence interval, all we have to do is to place the corresponding values for every component of the formula, including the z of alpha over 2, the sigma, the sample sizes. So that's for the both sides of the formula. Okay, so let's go back to our data. So based on our data, we have x1 bar. So if we set all the 1 under the group with the supplement and number 2 without the supplement, then 50 will be our N1. So this is our N1. And then 48 will be our N2. Sample mean 5.4 will be x1 bar, and 7.2 will be x2 bar. Sample standard deviation 1.3, that's our S1, and then 3.2, that is S2. The variances are the squares of 1.3 and 3.2. So once we have identified or labeled these numbers, we go back to our formula and place them in the formula. So with x1 bar minus x2 bar plus and minus e, so what we will have is that we have, so for the sample means, 5.4 and 7.2. So 5.4 minus 7.2, let's change the color. So we have, this is white. 5.4 minus 7.2, that is our x1 bar minus x2 bar. Plus and minus the e. The e is the one with the z of alpha over 2. So since our confidence level is 95%, this means that alpha, which is the complement, so this is 5%, because this 2 must be 100%. So if alpha is 5%, and since what we need is a z of alpha over 2, then we have to identify our alpha over 2, which is basically half of 5%, 2.5%. Or if you have written this as 0.05, so this is simply 0.025. So in the formula, you need a z of alpha over 2 or z of 0.025. Now, to find this number, there is a long way, and that is by using the z table. But if you have a list of the z, all you have to do is to locate or identify from your list what is the z of 0.025. You can have this list from online. You can take a copy. If you are given a set of formulas, normally you have this set of z's that are already given to you. So if I refer to my list, according to my list, the z of 0.025 is 1.96. So you need to verify this on your own, but from my list it is z of 0.025 is 1.96. So if we go back to our formula, our plus minus e, so e is z of alpha over 2, so focus here. Z of alpha over 2, we know it to be 1.96. 1.96 with the square root of those sigmas. Now again, the population standard deviation sigma is not known, so we have to make use of the sample standard deviations. So take note of the number 1.3 and 3.2. So from the formula, we have 1.3, which must be squared. According to the formula, there is a square. And 1 is we have 50 respondents from the group who are taking the supplement. Plus 3.2 squared over N2, which is equal to 48. And here you have already what you need to complete or to find the confidence interval. So you have to make use of your calculator to compute for the simplest form of this expression. Okay, so I'll compute first with my calculator and then I'll write the result. So first, my x1 bar minus x2 bar is 5.4 minus 7.2 is negative 1.8. So I have to add or subtract the 1.96 is square root or times the square root of 1.3 squared over 50 plus 3.2 squared over 48. If I will do that, then the value will be, so let me calculate, so I have 1.3 squared over 50 and plus 3.2 squared over 48, which will be multiplied to 1.96 times the value that I obtain up to 4 decimal places is 0.9744, because initially this is 3, 6, and 6 is higher than 5, so the 3 becomes 4. So we're almost done. So all we have to do is to add and subtract this number. Let's start by subtracting this 0.9744. So negative 1.8 minus 0.9744, and that is equal to negative 2.7744. And then if I add, so we have negative 1.8 plus 0.9744, that will give me negative 0.8256. So this is our confidence interval using a confidence level of 95%. Okay, so what is the meaning of this interval? So take note that what we are trying to do here is to estimate the difference between the two means, which is mu1 minus mu2. Take note, we're not estimating the difference between the two sample means, because what we are looking for are the difference, or is the difference of the parameters. Okay, but how do we interpret the negative 2.7744 to negative 0.8256? So the difference could be any value in between these two numbers. Now it's easier to think of the positive difference. That means if we take the absolute value of these numbers, it's like the difference will be about 0.8256 up to 2.7744. So meaning to say, the difference could lie anywhere between 0.8256 and 2.7744. So they could differ by maybe 1, because that's in between these two numbers. They could differ by 2, they could differ by 2.5, but they cannot differ higher than 2.7, like say if we say 2.8 or say 3, because 3 is already outside the confidence interval. Okay, so if they ask you, so about how large is the difference between the two population means, so a reasonable answer would be 1. They could differ by 2. So it's like if in terms of the number of days to recover, if the people who are taking supplement will have an average recovery time of 5, then the time for the people who are not taking the vitamin C could be only about until 7, but you don't say it's 8, because 5 and 8 already has a difference of 3. Okay, so that's the meaning of this interval. Now aside from that, another way to interpret the confidence interval is that when the interval, so even the positive version and the negative version, when the zero is not in the interval, when 0 is not in the interval, as we can see, because it started with 0.8256 and it is until 2.7744, so it means 0 is somewhere before this number, so 0 is not in the interval. So since 0 is not in the interval, we can interpret this confidence interval as there is really a difference. There is a difference, well, a significant difference between the two means, simply because the zero is not there, and zero means no difference. But since zero, this conclusion of no difference cannot be used, so we have to consider the opposite. There is a difference between the two means. In fact, they differ by about 1 to 2.5. Okay, or the difference between 2.7744 and 0.8256. So if zero is not in the interval, it means there is a significant difference between the two means. Okay, so just a quick recap on what we have done. We started with identifying what type of information that we have. We know from the very start that we are supposed to create a confidence interval, so we have to check what type of population what we have. We have two population means. What type of samples we have: independent, so again, people who are taking the supplement versus people who are not taking the supplement, they're independent samples. And once we identify the type of samples, we have to check whether the sample sizes are large or small. Okay, so here the sample sizes are large, so we have to make use of the Z. In another video, I will show one in which the sample size is less than 30, and if that is the case, we have to make use, or given that the sigmas are not known, we have to make use of the T. And then we know what type of information that we have. You get the formula for the confidence interval, and then from there, all you have to do is to place the corresponding numbers on the formula. And if you know how to place these numbers, it should not be, well, it's a kind of long process in a way, because you're substituting numbers one at a time, but the idea should not be complicated. Okay, you can even think of it as the difference between the two sample means plus and minus the margin of error. And then from that, once you have put the numbers, all you have to do is to get your calculator and input these numbers. Take note that you are getting two values, one with a plus from the difference and then one with the minus. Okay, so some consideration: when you find the Z of alpha over 2, make sure that you're using the alpha over 2 and not the alpha. Okay, so if you have 5%, that's 2.5% or 0.025. Also, I emphasize that if you have a list of Z, that would be helpful, because you don't need to trace or to identify what Z will we have if we have 0.025 as a subscript. So all we have to do is get that list, locate Z of 0.025, whatever the number is listed there, that's the Z that we need. Okay, so lastly, you need to know how to interpret our confidence interval. So this is how much they differ, okay, from 0.8256 to 2.7744. And I had a final note that if 0 is not in the interval, then that means there is a significant difference between the two means, because 0 means no difference. Okay, so I hope you were able to learn something from this presentation. And if you find something confusing, all you have to do is to review that part of the video and watch it again. Okay, thank you.